Let me start with a question. Have you ever deployed a microservice that worked perfectly in your local environment, passed all tests, reviewed by the team, and then broke in production? Timeouts, cascading failures, data inconsistency, and you spent hours debugging, thinking, what is wrong with my code? Here's the truth. Most of the time, it's not your code. Your code is fine. What's missing are the architecture patterns that hold distributed systems together under real-world pressure. No amount of clean code saves you if your architecture is not designed to fail gracefully. So what exactly are cloud design patterns? Think of them as proven, battle-tested solutions to problems that keep repeating themselves in distributed systems. And here's what makes them powerful. They are not tied to any language, not tied to any framework. These are architectural ideas that work whether you're on .NET, Java, Python, doesn't matter. They are used in real-world production systems at scale, at companies you've heard of. And Microsoft Azure, which is the platform we focus on here, officially documents 44 of them. 44 patterns that architects reach for when systems need to be resilient, scalable, and production-ready. Now, covering 44 patterns is a serious commitment, so we've structured this series into 5 phases to make it logical and progressive. Phase 1 is resilience, 7 patterns. Phase 2 is messaging, 11 patterns. Phase 3 is data, 8 patterns. Phase 4 is microservices, 13 patterns. And Phase 5 is security and ops, 7 patterns. Each phase builds on the previous one. By the end of this series, you will have a complete mental model of how production-grade Azure systems are designed. We start with resilience because when systems fail, and they will fail, these patterns are what keep them alive. We'll cover retry, circuit breaker, bulkhead, rate limiting, health monitoring, cache aside, and compensating transaction. Every senior architect knows these cold, and by the end of Phase 1, so will you. Phase 2 is messaging. This is about how services talk to each other without becoming tightly coupled. Publisher-subscriber, queue-based load leveling, async request-reply, competing consumers, claim check, and more. Decoupled communication is not optional in microservices, it's foundational. Phase 3 tackles data because storing and querying data at scale is its own engineering discipline. CQRS, event sourcing, Saga, Sharding, Materialized view, data partitioning, index table, eventual consistency. These patterns are the difference between a system that slows down at scale and one that thrives at scale. Phase 4 is microservices, 13 patterns for designing systems that grow without becoming a monolith. Sidecar, Strangler fig, Backends for Frontends, API gateway, Choreography, Orchestration, Service discovery, gateway routing, and more. This phase alone will completely change how you think about system decomposition. And finally, Phase 5, Security and Ops, because shipping is not the finish line. Running securely in production is. Secrets management, managed identity, key vault, monitoring and alerting, distributed tracing, auto-scaling, cost optimization. The patterns in this phase are what separate teams that react to problems from teams that prevent them. So here's what I want you to do right now. Follow the channel so you don't miss a single pattern, new pattern every day, clear and practical. And drop a comment below. Which pattern should I cover first? Circuit breaker? CQRS? Saga? Tell me. Your comment shapes this series. This is going to be one of the most useful series on this channel. I'll see you in the next one.